servers. What is the size of the data center? In how many acres? What is the approximate size? Is it equivalent to your college campus? Or maybe much bigger than that or lower than that? How many buildings?
Much bigger than that.
Okay, bigger in size or that's what they say, equivalent to a soccer ground. That's one data center. There are multiple data centers, multiple buildings. So it's a big facility. Take it this way, it's a big facility which is hosting anywhere from 60 to 80K or maybe 100K servers, physical servers. They are physical hardware, right? Okay. What about the storage? What is the amount of storage that they have? That's the servers, compute. Yep.
11 gigabytes.
11 petabytes.
Petabytes.
Terabytes or petabytes?
Petabytes.
Right? It's petabytes, guys, not terabytes. Is that a small storage or bigger storage?
Very big storage.
Okay. It's too much of storage. Petabytes. Right? Then is that the only storage or they have more?
More, sir.
Okay, great. What about connectivity? How servers are connected, how those hardwares are connected. What about electricity, power?
25 to 30 megawatts of power is required, and it want to one substation also.
Okay. If there is a power, outage, for how long AWS can run its data center without any interruption? For how many days?
That one I don't know, sir.
Okay. It is there in the video. Okay. What about security? What are they doing for security? How are they securing the data centers? Others?
Using
Cameras, two-factor authorization,
fingerprint face.
several layers of intrusion detection.
Fingerprinting. What did you say? Two-factor authentication?
Intrusion detection.
Anything else? What else? What else did you notice from the video? You're not audible. Can you repeat that?
In every second, 1 or 2 terabytes of data it will store it.
Okay. All right. Any other piece of information?
About cooling, it will uses a heavy air conditioners are using.
Okay. What about network connectivity?
Network speed is up to 40 GB, 10 GB to 40 GB.
Okay.
Gigabytes.
25 individual regions also it will available for data centers.
25 international regions.
Okay. All right, guys, let's do this. I would like you to watch those two videos once again in the evening today, and tomorrow we will have a discussion on it. And I want each one of the participant to provide one input. Okay. What about the other video, 3 minutes video? What it was talking about in that video?
Exact both are same.
Okay. No worries. Let's watch them once again, guys, and let's make notes because those two videos provides you a good amount of information with respect to how AWS is managing the data centers. In fact, for the security, did you not hear that they conduct regular audits, external audits, anomaly detection, and insider threats management, redundant power and network connectivity? So those are the keywords. Let's do this exercise tomorrow. But the purpose or the objective behind behind you watching those videos is to understand this technological arrangement, right? Now, a traditional data center, when I say traditional on-premises data center, it basically means a data center that you manage. When I say you, it basically means you're part of the technical team. Your employer or Genpact has its own data center in one of its office premises. So this is how a typical data center can be represented from the technology stack perspective. Let's start from bottom up approach. Let's see the bottom up. So it starts with networking. If you want to build a data center, the very first thing that you need to do is to lay out the cables, right? So you have networking, which means you have all the cables. Storage is nothing but the hardware. Servers, they are also the hardware. So the first three boxes represents the physical hardware, that you have a couple of networking devices, which are cables, routers, switches. Those are the networking devices which you will find in a data center. Then you have storage devices like hard disk, magnetic disk, uh, you know, uh, the SSDs. So the storage devices, and then servers. Servers are nothing but compute devices which have CPUs and memory. Now servers could be rack servers, blade servers, tower servers. Tower servers are the typical servers like desktop. Desktop has a cabinet. That cabinet has CPU, RAM, motherboard inside. That is known as tower server. Then you have rack server, which are kept in a rack, arranged in a rack. You have blade servers. So those are the arrangement for servers. So you have servers. So this is the hardware. Till this point, you have hardware. So this is your hardware stack. Then comes the virtualization. Do you understand, guys, what virtualization is? Okay, so I will not get into the detail of virtualization, but what you can understand that virtualization is a technology through which we can ensure optimal utilization of our hardware resources. That's what virtualization is. Using virtualization, we will break our hardware into multiple virtual machines, or we will host multiple virtual machines on our hardware so that the resources can be optimally utilized. That's virtualization is. So what happens? And virtualization is the backbone of cloud. Back in 1980s, 1985, when we had first, second generation of computers, when everything was hardware based, at that point in time, organizations or or corporates, they were wasting a lot of hardware resources because for each application they will need to procure a hardware, and if that application is not consuming that hardware optimally, then there is a wastage of resources, wastage of electricity. When the virtualization came into existence, it addressed that challenge of wastage. And now on the same hardware, you can provision multiple virtual machines, and that way you can utilize the hardware. So that's the virtualization layer. Through the virtualization layer, what we do, we provision virtual machines, right? That virtual machines has an operating system. When you provision the virtual machines on the hardware, you can provision a Windows virtual machine, you can provision a Linux virtual machine, you can provision a virtual machine which is running Mac, which is running Apple operating system, Mac operating system. Then you have a middleware. Middleware is the technology through which this hardware is connecting with the software, or the you're communicating with the hardware. Then comes the runtime. Runtime basically means that these virtual machines that you are provisioning here using the virtualization layer. So using the virtualization layer, the VMs that you have provisioned, virtual machines that you have provisioned, they are either running, they are in stop state, or they are either running or they are stopped. That's the runtime. Then what do you have? Data. You basically store some data on the virtual machine, and you have application, right? So this data and application is your service that you are hosting, right? So this is a typical representation of a data center from the technology perspective, technology stack perspective, that in a hardware you have this technology stack. Is that understood?
Yes, sir.
Okay. Now, this is your traditional on-premises data center. Can you tell me if cloud data center is different? Is cloud data center different from this? No. Cloud data center will be similar. In the cloud data centers, or the video that you have just seen, you have seen AWS data center there. AWS data center will also have similar arrangement, right? However, the difference lies here. In traditional on-premises data center, you as a customer or the technical team member, you manage end to end. The entire stack is being managed by yourself. You can see right from networking till the application, you are managing everything. So you are responsible for the hardware procurement, purchase of hardware. Then you need to deploy that hardware, install the required tools and terminologies, connect that hardware through networking, deploy virtualization layer, provision virtual machines, store data, and then host applications. You are responsible end to end. That's the difference. Now let's see what all options are available in AWS cloud or in a public cloud. The first option, the first service that you can consume, or the model in which you can consume the service, is known as infrastructure as a service. Infrastructure as a service. In short, we call it IaaS. IaaS. So this is how we write it. So we call it too small s. So I and too small a and then s. This is known as infrastructure as a service, the first model that you see. Now what happens in this model? Look at the bottom, networking, storage, server, and virtualization. It says managed by vendor. So the first four technology components are managed by vendor. Who is the vendor here in case of AWS? It is AWS, right? We are talking about AWS right now. So now this is common. This is common to Azure and other clouds as well. Wherever you see it says infrastructure as a service, it basically means that the hardware management is the responsibility of the vendor and the virtual machine that you provision. This is your virtual machine, right? On which you are hosting your application. And this is your application, which is nothing but your application and data, which is processed by that application. So your virtual machine and your service is your responsibility. So you manage. It clearly say you manage. That's infrastructure as a service. Wherein AWS is responsible for this. AWS will manage the hardware. They are responsible for the data center management. They're responsible for the security and everything. And you are responsible for the management of the virtual machine. That's what you're responsible for, right? That's infrastructure as a service. Any question on this?
No, sir.
All right. So that's infrastructure as a service, wherein the first four components or the hardware is managed by the vendor, which is AWS or cloud service provider, and you manage the rest of you manage your virtual machine. So when I say you manage your virtual machine, you are responsible for the monitoring, monitoring, patching, security of your virtual machine. You will need to deploy monitoring service. You will need to patch them, run Windows update. You will need to manage it. So that's your responsibility. Hardware is their responsibility. Virtual machine is your responsibility. That's infrastructure as a service. Now, the question is, let's say, consider yourself here when you are hosting your application in your data center and you are migrating to the cloud, right? Now, when you migrate to the cloud, you may say that, you know what, in my on-premises data center, I was responsible for the hardware, software, and application. In cloud, I'm still responsible for the software and application. What is the benefit? Cloud is taking half of the pain, but I am still responsible for monitoring, management, patching of my virtual machine and my application. And I need more benefits. I'm say I'm somebody who wants to focus more on business rather IT, rather managing the infrastructure. Is there any other model, any other option which is available? Yes, there is another option which is here, which is known as platform as a service. In short, we call it PaaS. This is how we write it, PaaS, PaaS. Now, what this model says, if you look carefully, now managed by vendor. Vendor is now managing this as well. Vendor is now managing the VM as well. VM on which your application is running. Vendor is responsible for the availability, monitoring, patching, security of the VM. And you as a customer are only responsible for your application and data. So whatever application you are hosting in AWS cloud, you're only responsible for that application and the data that that application processes, right? Or the store or the data that it needs to store. That's your responsibility. And rest of the pain is managed by the cloud service provider. That's platform as a service. Then, so now you're only managing your application. Now there's a high probability you may say that, you know what, I don't want to manage anything. I need a ready-made solution, a solution that I can directly consume. I don't have an application, but I have a requirement in mind. I need a solution through which I can provide capabilities to my employees to communicate and collaborate. Email solutions, Outlook. If that is the case, then we have a third option, third service, which is software as a service. And in short, we call it SaaS. In this model, you are not managing anything. It says everything is managed by the vendor here. End to end, the entire stack is managed by the vendor. It's like consuming a service which is readily available, like Office 365, M365, SAP, Salesforce, Microsoft Dynamics. These are the enterprise applications which you can directly consume. You don't need to manage anything. All you need to do, just go create your account, provide the information that they need and start consuming the service. So those are the three models which are available in public cloud. And if you look at this arrow, understand here it says more control because you are controlling everything. Here it says, and then it moves from more control to less control. Here it says less control because now you don't manage anything. The vendor manages, and in between you have control. Infrastructure as a service, you control the VM as well as the application. Platform as a service, you only manage your application. And in software as a service, you don't need to manage anything. That's the three service delivery models which are available in public cloud that you need to understand, and you need to have good clarity on all these models. Which is the most common, most favorite, or most widely used model? Infrastructure as a service. This is the most common and most widely used model. Most of the customers who are using or who are consuming services from public cloud, they are using infrastructure as a service model, or they are consuming services which are available as part of infrastructure as a service. That's what the customers are doing. Any question on this slide, guys? No question? Shall I move on?
Yes, sir, move on.
Okay, great. Now, let's talk about the benefits of benefits of cloud, or let's directly talk about the benefits of AWS cloud. Okay, let's see these benefits because you need to know. So those were the models. Now you know that if as a customer you want to consume or use services from cloud, those are the three models which are available. You can pick and choose one of them and you can start to consume services. But what are the benefits of cloud? That's what you need to also understand. So the first benefit is cost. Why cost is a benefit? Because if I want to build, let's say if I want to host an application, I will first need to build the infrastructure. I will need to purchase hardware, deploy it, configure it, and then install the application. So it's a 4-step process, right? However, in cloud, you don't need to purchase the hardware. You don't need to deploy anything. You don't need to configure anything. You can quickly subscribe to cloud, provision a virtual machine and host your application. So cloud is cost effective because it saves you from investing a lot of money, and it basically gives you pay as you go model. You only pay for what you use. You don't invest anything. So that's cost effectiveness. So cloud computing provides pay as you go or consumption based model, pricing model. And the benefits are no upfront infrastructure cost. When we start with AWS, when we provision our first virtual machine, we are not paying some initial amount to AWS. We are not paying $100, $200 to AWS to start with. There is no upfront commitment. And I'm not purchasing anything. That's the another benefit which I'm getting. And I'm not purchasing anything there. So no need to purchase and manage costly infrastructure. The ability to pay for additional resources when they are needed. So as I gave you the example that I can start small and expand. Now this is the, this is the thumb rule when you are using services from cloud. The thumb rule says start small and expand when needed. So I can start with a small configuration, which is like, let's say 2 vCPU cores and 4 GB of RAM, some 32 GB of storage. This is how I can start. I can build virtual machines with smaller configuration. And whenever I need more capacity, I can add it on the fly. So I can expand when I need, and I can pay the price accordingly. Now let's take this example. Let's say I start with this configuration, and this virtual machine is costing me $100 per month. This virtual machine, let's say. Now I am hosting an application on this virtual machine. Slowly and gradually, my business is gaining popularity, and now my application is getting more and more user traffic. More and more users are connecting to my application, right? Which means I will need to increase the hardware as well, increase the capacity so that users are not facing any performance issues. They are not getting the page not available or application not available issues. So what I will do, I will increase this capacity and I will make it, let's say 4 cores and 8 GB of RAM, and I will make it like 64 GB of storage. Now I will start to pay, let's say $150. I'm just taking the hypothetical scenario, guys. I'm not giving you the exact code that it will cost you $100. I'm just taking the approximate pricing. Now I will be paying $150. OK, now, for example, let's say now you are running a campaign. You are running an e-commerce website and you are selling products from your website. In the last couple of months, I'm saying you imagine you started your business in January this year. You hosted your website, and now the website has gained popularity, and now you want to run a campaign. You want to run an offer, some sale, and you want to offer products at discounted prices, much more discounted prices. And you are expecting that typically on my website, I get 50 to 100 users per minute or per hour. But when I will be running that campaign or sale, I will have 10 times of additional traffic. I will have 500 to 600 users connecting to my website, trying to purchase the product. That's the assumption that you will take. Would it not require you to increase the resources also so that the user experience is not hit? Yes, no, maybe. Guys, when there are more user traffic, would it not require more resources? Yes, you need to speak, guys. Otherwise, I will assume that I'm talking to myself and I will lose interest. Hope I'm audible.
Yes, sir, audible.
OK. So once again, I'll repeat my question. See, guys, I'm talking to millennials. You guys are millennials. You have more access to technology devices than what I used to have when I was into your, age. You have been using laptops. You've been using mobile phones. You have access to most of the, technologies. You have an account on Flipkart, Amazon, Instagram, Twitter, WhatsApp, Facebook, and whatnot. So you have more technical knowledge. You have more technology consumption than what I could have. So do you not realize that Amazon and Flipkart eventually comes up with Amazon Big Billion Days or different types of campaigns wherein they offer products at cheaper prices or at more discounted rates, and the quantities are very limited. So there are times when OnePlus or Apple releases their sale. The sale starts at 12 in the afternoon, and within an hour, all the inventories are sold. And you are trying, but you're just not getting hold of it. Did it not happen with you in the past, guys? Ever?
Yes, sir.
It has
Yes,
happened
sir.
with me a number of
Yes,
times.
sir.
Yes, sir.
Yes,
I
happened.
purchased the OnePlus mobile, and Amazon started the sale. The mobile was available at a discounted price. I logged into the website, but by the time I could select my product and add it to the cart, it was already gone. And I was waiting, and I was there in the waiting list. It happened with me a lot of times. Now, while this is happening, do you not realize that there are more number of users than the normal users who visits that website on a specific day? So what happens, what I'm trying to prove here is the how you can save cost. Now let's say your website is hosted on this virtual machine. All of a sudden you are running a campaign which requires more capacity. So what you will do at 12 o'clock in the afternoon when the sale starts, you will increase the capacity of the machine, of the website, of the machine which is hosting the website like this, so that it can accommodate more users, right? And at 2 o'clock, 2 p.m., when the sale ends, you will put it back to the same configuration. You will scale it down to the same configuration, which means for 2 hours, you were running at the higher capacity, and now you are back to the original configuration. So Amazon will not charge you $200 for it. For the next size, Amazon will only charge you the amount for that increased capacity for 2 hours only, which basically means that your monthly bill could be, if $150 you pay per month for this configuration, which is your original configuration, and if you have increased the configuration for 2 hours, and if the delta is, let's say, $10 for those 2 hours only, then at the end of the month, you will only pay $160 for that month only. And from next month onward, you will continue to pay $150. So what I'm trying to say here is that in public cloud, you have this facility that you can increase the capacity on the fly, use it for your business whenever it needs, and then you can get back to the original configuration, and they will only charge you for the time when you increase the capacity. Now compare it with on-premises data center. Is this possible in on-premises data center? The same concept. I'll start with this configuration, which means I'll purchase a hardware which has 2 CPU cores and 4 GB of RAM and 32 GB of storage. And I'll host my website on this hardware. Now I need more capacity. Will I have the capability to increase the resources in the same hardware? Will I have the capability? No. I will need to purchase a new hardware, right? Which means more cost, more money. So I'll purchase a new hardware with this capacity. Great. Then I want to run a campaign which requires some additional capacity. Will I be able to run that campaign from this hardware?
Sir.
No. Purchase another hardware with additional capacity. Right? This is now the question is, when the campaign is over at 2 o'clock, will I be in a position to return this hardware back to the vendor and get my money back?
Not possible, sir.
Not possible. In physical data centers, this is not possible. This is not purchasing a a garment or an electrical. This is not like purchasing a mobile phone from Amazon that you purchase it, it gets delivered, you use it for 2-3 days, and then you return it stating that it is defective. Businesses do not cannot go with this practice. That's not possible because purchasing a mobile phone from Amazon or purchasing a hardware from Dell, HP, or Lenovo is a bit different. First of all, you don't get it quickly. If I order it today, it will take anywhere from 4 to 7 weeks to deliver the hardware, which means I will need to plan in advance. If I want to run a campaign, if I want to do anything, I will need to plan in advance because the lead time to deliver the hardware is 4 to 7 weeks. Second, no return. I cannot return the hardware even if I'm not using it. So, which means that this is a wastage of money for me. Because if I host my website on this hardware, but my website actually requires these many resources, I'm wasting my hardware resources, right? So wastage of money. And resources. That's the another challenge. So that's the point that I'm trying to make here with this slide, that cloud is cost effective. Why? Because you don't need any upfront investment in cloud. You pay based on what you consume. It also gives you the ability to scale up the infrastructure on the fly whenever there is a need, and you can scale it back to the original configuration when that need is not there. And you will only pay for the increased capacity for the time that you had it consuming. That's the benefit of cloud. I hope this is clear to everyone. So the ability to stop paying for resources when they are no longer needed. Great. Now, this also helps you for a better cost prediction because now you will focus more on your business rather IT. The other benefit is economies of scale. Let's understand what economies of scale is. Let's take this example. If I purchase, now I'll use OnePlus example because that's the mobile brand that I'm loyal with, and I use OnePlus mobile phones. If I purchase 1 unit of OnePlus mobile, and if they give me 2,000 rupees of discount, will they offer me the same discount if I purchase 1,000 units of it?
No, no,
No, sir.
How much discount they will offer me? Less or more?
More, sir.
More. Okay, now take this example. You are the owner of Genpact, or you are the IT department head, and you are the decision maker. Now you go to IBM. IBM is the hardware manufacturer. IBM, Dell, HP, they are the hardware manufacturer. Most of the hardware that you see in data center is the compute hardware that it comes from IBM, Dell, HP. Okay. So as an IT, as an IT department head, you approach Dell and you say, Dell, I need 10 servers of this configuration. Okay. And Dell says, okay, for 10 servers of this configuration, you will need to pay $1,000. Okay. Let's do this example on the notepad so that you understand it. So you purchase 10 servers. The unit price of each server is $120 per server. You are paying 1,200 USD, right? Thanks, guys. This is simple math. You need to say yes, no, maybe.
yes, sir.
Okay. Dell says that they will also give you 10% discount. So you also get 10% discount. What will be the actual price that you will pay now after 10% discount? Is that the price that you will pay?
Yes, sir.
Okay, great. So this is you. Now I'm from Amazon. I'm the IT department head of Amazon. I go to the Dell and I say, Dell, I need 1,000 servers. And I'll go with the same configuration. How much will I be paying? This is the amount that I will be paying. Now the question is, what is the discount that I will receive from Dell? Same or more? You just answered this question, guys. When I'm purchasing more inventory, more quantity, I'll get more discount. I can negotiate with Dell and I can say, you know what, you offer 10% discount to others who only purchase 1, 2, 3, 5, 10 units. I am making an order of 1,000 units. I need 25% discount.
Yes,
Otherwise,
sir.
I'll go to HP or IBM because they are ready to offer me discount, right? So I'll get 25% discount. Right? This is now what will happen. Now suppose Genpact is also offering cloud service. Since I'm from Amazon, I'm also offering cloud service. Now tell me whose service will be available at comparative cost or cheapest cost. Who can provide service at the cheapest cost?
AWS.
AWS. Why? Because their cost is low. I would say when I provide a service, let's say if I'm providing a service, I will, before I provide a service, I will tell you the price of my service. And how do I calculate the price? By taking into consideration all the factors that what the service is costing me, what is the percentage of revenue that I want to get or percentage of profit that I want to make. Then accordingly, I will make my service price. Now, if from this amount, if Genpact is hosting a virtual machine, Genpact is giving a virtual machine to a customer, the cost of that virtual machine, if Genpact is putting as let's say 15 US dollar, AWS can actually offer the same virtual machine to a customer with the same configuration at $10 because AWS paying less price. Is that a possibility? This is similar to wholesaler and retailer. You go to a retail shop, you purchase a product, you pay 10 rupees for it. You go to a wholesale shop and purchase 10 quantities of that product. Each quantity will cost you 8 rupees only because you get more discounts there. Am I making sense?
Yes,
Yes,
sir.
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 This
Yes,
is
sir.
exact. This is what known as economies of scale. So economies of scale says that if you purchase services in bulk, you get more discounts. You get those services delivered at lower price, and you can pass on those discounts to your customers and provide them services at a comparative or cheaper cost. That's what economies of service scale is. So if you purchase a service from from a service provider, which is a low medium scale service provider, the services will be costlier. But if you purchase the same service from a service provider, which is a global service provider like AWS, the services will be cheaper. The performance will be the same. The configuration will be the same. The service unit cost will be cheaper. Why? Because they are getting more discount and they're passing on these discount to their customers. That's what economies of scale is. So economies of scale is the ability to do things more efficiently at a lower cost per unit when operating at larger scale. Since AWS operates at larger scale, AWS offers you lower cost per unit more efficiently. So it says cloud providers are large businesses leveraging the benefits of economies of scale. Now you can see these providers can then pass the savings on to their customers. Cloud service providers can also make deal with local governments to get more tax savings for you, lower pricing on power cooling and high speed networks. So that's the benefit. So it clearly says that cloud service providers can purchase hardware, which is storage compute network, in bulk at lower cost and pass on these benefits to end users. End users are you as a consumer. To end users in the form of lower prices than what you could have achieved on your own. So if you are the end user and if you have two choices, whether you build your own data center or you consume services from AWS, I think you should go with AWS because in AWS, you will be paying less money for the same service. That's what economies of scale is. Any question on this, guys? The other benefit of cloud is, now you can consider them cloud benefits or AWS benefits. It is one and the same thing. Move from CapEx to OpEx. CapEx means capital expenditure. Capital expenditure means spending money on infrastructure upfront, like purchasing hardware. And operational expenditure means that you only pay for the products basis on the usage. So cloud basically helps you to move from capital expenditure to operating expenditure, which means in cloud, see, imagine if you're not in cloud, then you're spending lakhs of rupees to build a data center first. And then you will host your services in those data center. But in cloud, you're not even spending a single penny. You directly subscribe to cloud and you start to consume services from there. And you pay at the end of the month for the consumption only, no hardware cost. Which means you are not needed to set aside some budget for the capital expenditure. And you can actually use that money for your business and you can make your business more profitable. That's the benefit of cloud, that it lets you move from CapEx to OpEx. Next benefit is agility. Agility basically says, I was giving you the same example, that if your service peaks 1 month, if there's a peak demand in your service because of a product that you are selling which is gaining more popularity, or maybe you are running a campaign, you can scale to demand, you can scale your infrastructure to demand, you can increase the capacity, pay a larger bill for that month only, and in the following month, if the demand drops because you have stopped running the campaign or that product is now being available with your competitors as well at discounted price, or that product has no more popularity, in that case, the demand will drop. In that case, you can reduce the used resources and you will be charged less. That's the benefit of cloud. So that's agilities. Now, how this is possible? Through scalability. Scalability is of two types. Vertical scaling, which means that you can add resources to increase the power of an existing server. The example that I was taking, wherein you start with 2 CPU cores, 4 GB of RAM, 32 GB of storage, and there is a demand increase, then you can add more resources to the same server, 4 GB, 8 GB you can make. That's vertical scaling. Then there is another type of scaling, which is horizontal scaling. Horizontal scaling basically means instead of increasing the configuration of the same server, you build another server of the same configuration and add it to your application. That's horizontal scaling. So here you have this server, let's say, with 2 CPU core, 4 GB RAM. Now you are scaling it up and you are adding more capability here. This is vertical scaling. Horizontal scaling basically means that you have a server of this configuration, you need more capacity, you build another server of the same configuration. That's horizontal scaling means. Both of the options are available manual as well as automated. You can manually scale it up, scale it down, and you can automatically do it also. That scaling is. Is it making sense, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Elasticity. Elasticity basically it is one and the same thing. Agility, elasticity, flexibility, they are similar terminologies in case, in the context of cloud. It says automatically add or remove resources based on demand. You need more capacity, add it. You don't need it, remove it. That's what elasticity is. Then comes availability. Now, this is the most important thing. A cost is not everything that a customer is bothered about. It is the end user experience also. See, I have money. I can spend more money, but I want my customers to get good experience, to get, to provide me, to have good experience, to get good feedback. That's what I want. So I can use services which are highly available. So cloud provides you highly available services. How do they provide highly available services? They have data centers which have thousands of racks of servers, and they are copying data from here and there. They are keeping multiple copies of the data so that if one copy is lost, they will be they will be retrieving the data or restoring the data from the other copies. Those are the options through which they provide high availability. They also keep your services across data centers. You will see how AWS provides high availability in the subsequent slides. And disaster recovery also. So for example, let's say I'm hosting an application in these 3 VMs, right? And I'm load balancing the traffic using a load balancer. This is my load balancer here. And what is happening? This is where the user is sitting with his laptop, and user is using my service. So user sends the request, the traffic goes to the load balancer. Load balancer sends that traffic to one of the VMs, which is hosting the application. Let's say this VM goes down. The other two will continue to run, which means my application will still be available to users, right? If this goes down, this one will continue to run. My application is still available, and within this time frame, I will bring these 2 VMs up. I will fix them also. So I'm so this arrangement is making sure that my application is highly available, right? But what if the entire data center where all these 3 VMs are hosted is down? Then my application is not available. For that, I have another arrangement, which is disaster recovery. I will have my application also hosted in the other data center, DR site or the secondary site. And whenever the primary site is not available, I will change the connectivity to the DR site, and the application will be available from the DR site. That's the another arrangement. So we have fault tolerance. Fault tolerance basically means when one of the VM hosting the application goes down, the others will continue to support the application availability. Disaster recovery means when the entire site is down, you will have another secondary sites or disaster recovery site from where you can have your application up and running. That's disaster recovery is. So cloud provides you both the capabilities, and that's the reason cloud is highly available. Now you can also configure this in your on-premises data center. It is not that you cannot have highly available applications in on-premises data center. You can have, but in order to build this configuration in on-premises data center, you need to invest a lot of resources. Cost is one resource, and then human. People who understands how disaster recovery sites are configured. You need to do all of it. But in cloud, you don't need to do that. That cloud vendor will take care of it. So that's the availability. Global. Now the other benefit of cloud is global. When I say global, it basically means it basically means that cloud data centers are available in most of the regions across the globe. or in most of the countries, most of the locations. So if I have a product that I want to sell in Australia, how will I sell it? Either I will have my website available in Australia, hosted in India, but there is a concern, security concern. If consumers from Australia purchases a product from a website which is hosted in India, are they not providing their information while making an order? Like their credit card information, their personal information, their billing address, shipping address. And if that happens, it's a violation of, it's a security issue, similar to what happened to TikTok. Australian government may not allow their residents' data to be stored and processed outside their boundaries. So what will I need to do? I will need to host a local instance of my application in Australia so that people in Australia can connect to that application instance and consume the services from there. Then I will need to create a data center in Australia, build a data center to host that instance, which will involve a couple of days, a lot of money, and then the management overhead, right? I can save myself from all of this by using services from public cloud. I can quickly build a virtual machine in Australia in AWS, and I can host my application there. So this saves me from waiting for a couple of days to get that data center built, to have the servers deployed and installed, and then I will have my application up and running. That's the benefit. So cloud is global. Wherever your customers are, you can quickly host your services in that region. That's the benefit. The benefit is security. Now, so far I was telling you that due to security, some customers may not agree to migrate or host their application in cloud. However, now I'll change my statement. Cloud is more secure than your on-premises data center can be. Why? Because cloud service providers, they have more budget, they have more talented people, security specialists who are working for them, whose job is to ensure the security of cloud data centers and security of the data which their customers are storing in those data centers. So cloud is actually more secure. However, it has a shared responsibility model. Since it is your data and someone else's data center, you as a customer and cloud service provider as a provider of service, you both share the responsibility when it comes to security. So security is a shared responsibility model in cloud. However, cloud service provider, you already have seen from that video that they are putting in CCTV cameras, they are putting in biometric devices, they are putting in, two-factor authentication. It is not easy for anybody to go and get access to that data center, to go inside the data center. They have to go through multiple level of scrutiny, security. So cloud is more secure than an on-premises deployment can be. And cloud data centers comply to all the regulations and certifications. These are some of the regulations and certifications. CJIS, GDPR, which is applicable in Europe. You have HIPAA, which is related to healthcare industry. You have ISO certifications, SOC certifications, NIST framework. So cloud data centers basically comply to most of the security requirements related to a specific geography or related to regulations and compliances. So cloud is actually more secure, guys. Now this is about major cloud vendors. Take that part. Okay. So those were the benefits of cloud. Now we'll focus more on AWS. So let's see the AWS history. This is not AWS history, this is Amazon history. We all know that Amazon is a company which was founded by or incorporated in 1994 by Jeff Bezos, who also happens to be the richest person on this planet as we speak. As that changes, it keeps on changes. Sometimes somebody else takes over, but he has been the richest person on this planet for some time in the last couple of months. Let's say if he doesn't continue to be the one as we speak. So he started this company back in 1994, and initially he started selling books. That was the business that they started with. If you look into the history of any successful company, you will find that they are successful today by virtue of a product or service. But in reality, their actual product was something else when they started. That's the irony. Do you know how Flipkart in India started? What business did they start with? They were also selling books online. They copied Amazon concept. They started as an online book shop. So you can purchase books, DVDs, you can rent books and DVDs from Flipkart. And later on they entered into this e-commerce, I'm saying into this consumer segment market wherein they added more products, and today you already know what Flipkart does. So that's how Amazon started. They started as a company which would sell books online. Then in 2005, the Amazon Publishing, they initially they would sell books online. Then later on they launched their own publishing house wherein they started printing books. In 2006, this is where you need to start or remember always. In 2006, they launched Amazon Web Services, the product that we know today, Amazon Cloud. So it started in 2006. And from 2006 till 2012, where we are right now, Amazon has been into the market for last 15 years. And it has grown from leaps and bounds. And today, Amazon happens to be the largest or the leader when it comes to public cloud in the segment. Simultaneously, Amazon as a company also launched a couple of products like Kindle, Game Studios, Amazon Fresh, you already know, Amazon Art, Amazon Home Service, all of this. So we are not bothered about it. Let's just focus on Amazon Web Services journey. So when they started back in 2006, so there's a theory behind it. So it is not that they launched this product all of a sudden. So the theory is, the history is that for their own online bookstore or their own publishing house, they had a couple of websites, those they were hosting. They were facing a lot of issues related to availability, customer experience was not that great. Customers were complaining that their website was quite slow. There was connectivity issues. The website would not be available all the time. A lot of issues were there. And that's where Amazon thought, instead of depending on people like GoDaddy or other hosting service provider that they were using at that point in time, let's create our own hosting solution. Let's build our own service. And that's where they built their own hosting platform. And then they hosted their own website into their hosting platform. The response was great. Customers' experience increased. They were not getting similar issues of outages or performance issues. And it really worked out for them. And that's where they decided to make this service available to public at large, to other customers. And that's how Amazon was born. So it started as a hosting platform with services like storage, compute, and networking services to begin with. And then then later on, they kept on adding more and more services to their ecosystem. And today you already know that they are the leaders. So that's how Amazon was started. I hope this is making sense, guys. Yes, no, maybe.
Yes, sir.
Okay, now let's look at the history. So in this slide, you also have the similar information for Google and MS and Azure, because it's a multi-purpose, presentation deck that I use. I use this deck for other cloud trainings. I use this DAT for foundation training. I use this DAT for intermediate and architecture level training as well. Okay, major cloud vendors, AWS. Now you can see, so this is some critical information. AWS stands for Amazon Web Services, which is a subsidiary of Amazon, and it is focusing on cloud services. It was started in Cloud IaaS market in 2006. It's headquartered in Seattle, Washington, USA. The CEO of Amazon Web Services, not Amazon. CEO of AWS is this, and he has been the CEO from this date. Offerings, what do they offer? They offer virtual machines. They offer bare metal servers, hypervisors. I would say they use virtualization, so their hypervisors are based on Xen and KVM. They offer storage as well. You can in fact use VMware on Amazon. Location. Now Amazon groups its data centers into regions. So we use the terminology regions. I will say Amazon has 25 regions. Amazon has 50 regions. Regions means collection of data centers. A region has multiple data centers. Okay. And in each region, they have two availability zones. Availability zones are nothing but the data centers also. I'll explain what availability zone is in subsequent slides. So Amazon, so just understand that Amazon is AWS is a global cloud service provider. It has its data centers across multiple countries in the world, and they use the concept of region. Region means a collection of data centers. Those regions are Canada, France, Germany, UK, Australia, India, Japan, Singapore, almost everywhere. And Amazon also have dedicated regions for US government. Now this is where the GCC comes into the picture. I was talking about government community cloud. Anything, so Amazon has dedicated regions where only the government of US or various states, government of US can only host their services, host their applications. It is not available to other people, other customers. And that's what makes it GCC, Government Community Cloud, because it is only meant for that government and it has been created keeping in mind the specific requirements from the government. As we speak, it has 26 regions. This 26 regions also includes these government regions. So AWS has 26 regions and they have also announced 8 regions. 8 regions means that they will be expanding their services to other locations as well. Strength, they have been the leaders for the last couple of years. They are the pioneers. Most of the Fortune 500 companies are a customer of AWS. Those are the strength. Now let's understand AWS global infrastructure. So AWS global infrastructure is secure, extensive, reliable, and it offers more than 200 fully featured services from data centers globally. These 200 services are native and they are built by AWS itself. Then we have marketplace. Marketplace means additional services that you want to procure. They're also available through AWS Marketplace. It enables the customer to deploy applications across the globe within a single click, along the capability of deploying specific applications closer to end users. All the capabilities are there. Amazon has millions of active customers, tens of thousands of partners globally. Partners are companies who are providing services to AWS customers. So, for example, if Genpact does not have expertise with AWS, but Genpact wants to move or build services in AWS, Genpact can connect with Wipro, Infosys, TCS, IBM, HCL, and take their help to build services in AWS. That's the partners. So Genpact is also a partner of AWS. Public sector organizations also. Now here you can see at a glance what they have. AWS has 26 launch regions, 8 announced regions, 84 availability zones, 245 countries in which AWS countries and territories where AWS is offering its services, 108 direct connect locations, 310 plus point of presence, edge locations, regional edge locations. This is how global infrastructure of AWS looks like. Now, how do you look at this global infrastructure? There is a high probability that some of this information may not be up to date. Cloud is very dynamic, guys. If you really want to know what is the most recent update, you should always visit the cloud service provider's website. Do not depend on information that you see in a presentation or any other website, because that information may not be 100% accurate or up to date. So you should always look for the website. What you need to type in Google: AWS global infrastructure, and the first link that you get here, global infrastructure, you need to click here. I'll put it into the chat window as well. On this link, you will get every minute information about AWS and most recent information, because it is from the AWS itself. So here you can see 26 launch regions, 84 availability zones. Now my presentation is also up to date, guys, because before any training, I always make sure that I go through all the slides in my presentation and update them if required. But I was just giving you a clue that never ever depend on the information that you seek from a presentation or a third-party website. Always and always go to the OEM website. OEM means original equipment manufacturer, or the website of that product and service, and seek information from there. 8 announced reasons, all of the information that you see is there. Now, I was talking about AWS is a leader. So let's see the report here. So if you look at this report from Gartner, here's the report from Gartner. What Gartner does, as I said, Gartner is a company whose job is to study various technologies and services available in the market, various products across a specific category, and come up with their analysis and share this information with the world, with the rest of the people, that who is the best, who is providing best services. So that's what Gartner is. Gartner releases its magic quadrant. Quadrant means 4 squares. This is a quadrant. This has been divided into 4 squares here. This is known as quadrant. So Gartner releases its magic quadrant every year across multiple services. So if you look at the Gartner magic quadrant for cloud infrastructure and platform services, this is where the companies are. It has 4 quadrants: visionaries, niche players, challengers, and leaders. And if you look at the leader quadrant, Amazon Web Services is at the top. At second place, Microsoft Azure. Third place, Google Cloud. So these are the leaders where Amazon is leading the chart. In infrastructure and platform segment, Alibaba is actually entering into the quadrant. Alibaba has made a space into the quadrant, and it has almost at the end of visionaries, and very soon, most probably this year in July, when they release their quadrant for July 2022, there's a high probability that you will find Alibaba either in the niche player or challengers quadrant. Probably Alibaba will make it to the challengers quadrant, because Alibaba is also expanding their services and portfolio very quickly. And I have in fact seen some of the customers switching from these 3 leaders to Alibaba, because their services are available at a cheaper cost and they are giving more benefits. So let's see what happens. But this is what Gartner released last year, wherein Amazon Web Services has been the leader, has been identified as a leader in July 2021 but that is not all. Amazon Web Services has been a leader for the last 10 years. For the last 10 years, they have continuously been a leader. That's what AWS Web Services is. If you want to read this report, you can read this report. All you need to do on this page, the link that I've given, you just need to click on this. You can read the full Gartner report here. Click on this hyperlink that will take you to the report. You can read it. Okay, let's see the global infrastructure map of AWS. This is where the AWS services are. The blue circle represents regions which are available, and the amber or saffron one shows the coming soon. This is, what is this, guys? US. So you can see Amazon is available in Oregon, North California, all the information is there, right? This is your South America, Sao Paulo. This is where India is. Amazon is also available in Mumbai, in India, which was launched in 2016. And Amazon is coming up with another region is Hyderabad. So the next region of Amazon is in Hyderabad, which says coming soon. Similarly, if you see here, this is Europe. In Europe, they have its presence in Stockholm, Sweden. They are in Ireland. They are in Paris, and they are very soon launching a region in Spain as well. So in Europe, they are coming in two regions, Spain and not able to click on that one. Yep. Switzerland. So Spain and Switzerland, they are actually coming up with very soon. They also have one region here in Cape Town, South Africa. Then they have a region in Australia, New Zealand. Also, you can see here Melbourne, which is in Australia. They are coming up, and they have one region in Sydney. Sydney again in Australia. So they already have a region in Australia. In 2012, they launched. So you can see the global presence of AWS in this slide. This is your Asia Pacific region over here. So they have presence in Hong Kong, they have presence in Seoul, they have presence in Beijing, China, they have presence here. They also have presence in Osaka, Tokyo, Japan. So they have presence there. They also have presence in UAE. They also have presence in Bahrain. They have presence in Israel. They don't have presence in Bangladesh, Pakistan, and the nearby countries. So those are the locations for AWS regions or AWS data centers. Any question on this, guys? Yes, no, maybe? Guys, you need to acknowledge. Otherwise, how will I know that that I was audible? You were actually listening to me. I may assume that there was a network.
No doubt, sir.
Okay, great. So moving on, benefits. Now, these are the benefits. I already have talked about these benefits already. Let's talk about them once again. Security, as I said, cloud is more secure, be it AWS, Azure, GCP, any cloud. Cloud is more secure than an on-premises deployment could be. Why? Because cloud service providers have more budget to invest into security. They have more talented people, subject matter experts across various security domains to actually ensure that cloud data centers are more secure. And they're investing more money into security. So cloud is secure. Availability, as I told you, cloud is highly available because what they are doing, first of all, they have multiple locations. The data that you keep in cloud, they create multiple copies of that data and they save those copies in the same data center and across data center as well. So if your original copy is lost, they can restore your data from the backup copies. That's how cloud is highly available, resilient, and fault tolerant. Then comes performance. Cloud performance is better than on-premises because they are using state-of-the-art technology. Look at this speed. They use 100 gigabit Ethernet fiber optics network cables for the communication. They are very fast, communication media. In your BTech, if you're from, in most of the colleges, most of the universities, the first year is common to all the BTech programs. And in the first year, they teach about, technology as well. So if you have read about communication medium or networking topology, optical fiber cables are the most efficient and most capable communication medium because their transfer rate is much higher than the typical coaxial cables. So they use optical fiber cables for transfer of data from one data center to another, from one hardware rack to another hardware rack. And that's the reason their performance is quite good. Global footprints, you already have seen here in this slide that they have global footprints. Scalability, yes, I have explained you a number of times that you can scale to demand. The demand increases, you can scale. When the demand goes down, you can scale down. Flexibility, yes, it gives you the flexibility because it doesn't stop you. Whenever you wish to scale up, you can scale up. Whenever you wish to scale down, you can scale down. If you want to build a server in a different region, you can do it quickly. They will not ask you to first fill a form and justify why you want to build a service in Australia, why you want to build a service in China. They will not ask you these questions. As a customer, all the regions are available to you. You can quickly pick and choose a region and start to build your service, start to make your service available in that region. That's flexibility is. In fact, if there are regions where services are not available, then they have the concept of local zones, wavelength, outpost that I will talk about in subsequent slides, that how AWS is making sure, because in this graph, you will see that there are some regions in this map, world map, where you do not see AWS regions. So how AWS is providing services here. For example, in the entire South America, they are only present in one region here. But what about other countries in South America? Right? What about other countries here? What about other countries in Europe where AWS is not available? How AWS is making sure that its services are made available to those regions is something that I'll show you in the subsequent slides, which also covers the flexibility part. So those are the benefits of AWS. All right, so you already have taken the tour of AWS data centers, those two videos that we will once again, do tomorrow, first 10-15 minutes tomorrow. We'll talk about the key pointers. I'll quickly move on with the key pointers so that you don't see it. All right, that's this slide has been taken from the same documentation that I was just showing, and at the bottom you see the reference also, so that you can always go to the AWS documentation and find the most recent information. Benefits I have just talked about. Okay, this is where I want you to focus on. Okay, before I explain the slide, I want you to just read it. Give yourself 2 minutes. Try and uh, comprehend the slide as well as the image that you see there. Then I will explain it. All right. So as I was telling you guys, any cloud, be it AWS, Azure, GCP, Oracle, IBM, Alibaba, Cloud4C, Rackspace, and whatnot. All the cloud service providers, they follow shared responsibility model. Why? Because infrastructure is their responsibility, and anything over and above virtualization layer, depending on the service delivery model that you pick and choose, which is IaaS, PaaS, and SaaS, is your responsibility. And some of the components will always be your responsibility. So AWS follows shared responsibility model. Look at the image, you will understand it. Now, AWS has divided security into two segments. AWS says that responsibility for the security of the cloud, which means security of the cloud is our responsibility, and security in the cloud. So security of the cloud means the cloud data center security, which is compute, storage, database, networking, all of these components. This is our responsibility. The hardware and software component is our responsibility. Regions, where are we opening our data centers? They're doing all the research. They will not open a data center in a region which has seen a lot of conflict, like Somalia, any regions where you have war-like situation. So that is their responsibility. Availability zones, edge locations, their responsibility. So responsibility of the cloud is cloud service providers' responsibility, which is AWS in this case, and responsibility in the cloud is your responsibility as a customer. For example, your data is your responsibility. You will store your data. You will decide who you want to grant access. How do you want to keep your data? Whether or not you want your data to be backed up. If yes, then for how long you want to retain it. That is your responsibility. Customer's responsibility. Platform application identity and access management. Platform, how you want to, which platform you are choosing to store your data, which platform you are choosing to host your application. Are you using Linux platform? Are you using Windows platform? Are you using Java? Are you using .NET? That is your responsibility. Application is your responsibility because that belongs to you. Identity and access management. Who will have access to your application? What level of access they will have is your responsibility. Right? So you will be creating users, you will be granting them access, you will make them administrators or read-only users. That's your responsibility. Operating system, network, and firewall configuration, your responsibility. Since you are deciding what operating system you need your application to host on, how you want to enable the networking communication, that how your application will communicate with different tiers, what security measures you want to deploy, whether you want your application to be accessible over the internet or internal to the organization, whether you want your application to communicate with other applications in your AWS cloud, that's your responsibility, right? Then client-side data encryption and data integrity authentication. I would say if your application is using client-server architecture wherein users are connecting to your application and users are sharing data, transferring and downloading and uploading data in your application, that's your responsibility. You will decide if you want that entire communication to be encrypted. If yes, then what will you be choosing? Will you be encrypting using certificates, using SSL, keys? That's your responsibility. Server side encryption is your responsibility, and network traffic is your responsibility. If you want to enable traffic, if you want to disable traffic, that's your responsibility. So security in the cloud is your responsibility. Security of the cloud is AWS responsibility. This is known as shared responsibility model. If you want to read in detail against each terminology, what it means, you can read, you can just type shared responsibility model and you can go through it from AWS context. Whatever I have just explained you in this image is exactly written here. You can take the example here security in the cloud, it says it is determined by AWS cloud service that you select. For example, if you are provisioning a virtual machine service in AWS cloud is known as EC2, Elastic Compute Cloud. Virtual machine is an infrastructure as a service, right? So every service that you consume from AWS cloud will fall in a category of either IaaS, PaaS, or SaaS. And depending on the category that it falls in, the security responsibility changes. Just try and revisit that image that I showed you, that in infrastructure as a service, anything over and above virtualization layer is your responsibility. So if you are provisioning an EC2 instance, a virtual machine in Amazon, then it is your responsibility to make sure that the virtual machine is up and running, that the virtual machine has an antivirus, anti-malware, anti-spyware software on it, that the virtual machine is being monitored for its availability and performance, that you are running, that you are ensuring that the virtual machine has an operating system which is up to date from the patches and update perspective. So that is your responsibility. So that's what this example is saying. Then comes the guest operating system. Guest operating system is where the virtual machine is running. Then there's a host. Host is the hardware, which is the hypervisor. So host is AWS responsibility. So that's how the responsibility is divided. And for each service that you have in AWS, there is an SLA. SLA from the availability perspective, not from the security perspective. Security is always a shared responsibility. And another thing that you need to keep in mind, security cannot be an afterthought. It cannot happen that you first build your application in AWS cloud and then you secure it. No, you will need to bake security into the design right from day one. Then only your application will be 100% secure and compliant. So you will need to first build the infrastructure, put the guardrails, security controls, and then start to host or migrate the applications. That's what you need to remember. If you do it the other way, then you will have security misconfigurations, which will lead to security incidents, which is not the right approach. Any question on this slide, guys?
No, sir.
Okay, great. This is making sense to you. I can understand your level is very basic when it comes to cloud, but I'm trying my level best to explain these terminologies in a language which makes sense to a layman as much as possible. I'm not using technical jargons. I'm not using complicated language. I'm just making it as simple as possible so that you guys understand it, because it is the same slide that I explain it to architects, explain it to security people who have couple of years of experience in the industry. And it is the same slide that I'm explaining to you. The difference is my difference lies in the example and the choice of words that I make here. Okay.
Sir, lunch break.
Yep, that's what I was about to say, because this next topic will take time. So let's take break, lunch break. Is 45 minutes sufficient, guys, for lunch break? Can we take it for half an hour or 45 minutes? I leave that decision to you guys.
45 minutes.
45 minutes. Okay. So it is 1:35 or 34 minutes past 1 here. Let's all of you be back by